Hi, in this video, I'm going to go over game 3 from Prep Test 26. I'm going to do the setup and the questions for this one. All right, so each of exactly 5 persons, these 5 people are going to be our players, um, participates in exactly one of 3 activities. So those activities are going to a movie. So we'll do lowercase um, for these ones. We've got movie, soccer game, and restaurant. So we could maybe do groups here, but just yeah, just looking at the first. Um, yeah, so I think they're all. It's just grouping. We have these 3 different groups. Um, but the way that they're listed in the first question kind of makes it look like it's ordering. But it's not. That's just how they chose to write out the first question. So we can set it up as a grouping game. That's fine. N and O don't participate in the same activity as each other. So they are not together. And neither one of them participates in the same activity as P. So N and P aren't together, and O and P aren't together. 2 people go to a soccer game. Exactly. Exactly 2 there. T and P don't participate in the same activity as each other. Wow. Okay. So we've got um, a lot of players that cannot participate in the same activity as P. So if P, for example, goes to the soccer game, we know that someone else goes to the soccer game. The only one that could be there with P would be V. And then we have rule 4, we have a conditional rule. So if N or V goes to a movie, so if N movie or V movie, then they both go. Okay. So let's uh, let's take a moment to think about another way that we could write this out. We could write this out as a biconditional. So if N goes to a movie, then V does. If V goes to a movie, then N does. It's actually going to create a biconditional. And because of that, we know also that if one of them doesn't go to a movie, then the other one won't go to a movie. So it's either both of them go to a movie or um, neither of them. Um, if we trigger that, just sometimes that's good to just create one world based off of triggering a rule that is quite consequential. We would have movie is both N and V. And then who do we have left over? We have O, P, and T left over. T can't be with either O or P, so it can't, that person can't go to the soccer game because we have to fill those 2 spots for the soccer game. So T by himself would go to the restaurant, and O and P. Ooh, O and P can't be together either, can they? And why? Oh, wait, T. Sorry, P is the one. P is the one that can't be. Okay, so the logic holds. I just got P and T confused. So P can't be with T or O, but O and T can be together. So yeah, if either N or V goes to the movies, then this would be the only solution that we could get. If neither of them go to the movie, then we don't know, right? I mean, we could write out that world and see what our options are. But that's probably not something we want to be doing at the beginning. That's probably not going to be very efficient. So that's what we're left with as just one possible solution based on triggering this scenario. Okay, going to question 13. So question 13, we've got our potential answers there. And we're going N, O, P, T, V, like that. Okay, so if N goes to a movie, we know V has to as well. Let's see if we can eliminate anything based on that. N is at the beginning, V is at the end. So if one of them goes to a movie, they both have to go to a movie. C we can eliminate based off of that rule. So C is out of the running. Okay. All right. We can't have N and O go to the same activity, so the first two can't be the same. Okay, so none of the examples have that error. And then O and P can't go to the same one, so the second and the third in the list can't be the same. So that means that A is out. Then the first and the third can't be the same. Okay, so first and third. Okay, so nothing breaks that rule. We have two people going to a soccer game, so we have to see soccer game twice, exactly twice. So E is out because it's 3 times. Right? And then T and P don't participate in the same activities as each other, so 3 and 4 can't be the same. So B is out. That one. So D's got to be the correct answer. Let's write that out in our format for the acceptable solution. So I have M, S, R, and for this one, so soccer game, we have N and T going to the soccer game. For restaurant, we have O and V. And for movie, we just have P. Which makes sense that P is going to be on its own quite a bit because of all of these rules. Okay. Question 14. If V goes to a soccer game, right? So V to a soccer game. R, V is here. So that does mean that N can't go to a movie. Okay, so N can't go to a movie. What else? Let's see. So since these guys can't be together, we're going to sort of run into an issue where, we have to like separate all of them, right? So like so N can't go there, right? If we put N in that soccer game, then that's great. But if we try to put N over here at the restaurant, then we would know this can't be O, like O and P can't go there as well, right? And O and P can't be together. So one of them would go to a movie and the other one would go to the soccer game. So we really got a situation where um, one of them has to be in each group in order to keep them all separated. Okay. So for sure, one of them is going to have to go to the movie, either O or P. N could go to the soccer game. So we could have N or O or P be there, but one of them has to be. And one of them also has to go to the restaurant. Okay. T is left over, and the only player that T can't join would be P. Okay. So what can't happen out of these options here, so like O can go to the movie, that's fine. N could go to the restaurant or the soccer game, that's fine. T can't go to the soccer game because the other player that goes to the soccer game besides B has to be one of these three players so that they're all separated, right? It has to be either N or O or P. Um, you could kind of play each of these out. Um, like, you know, you could have created an example where O goes to a movie and you would have found out that that was possible to do that. And so you can eliminate A and then you can eliminate B, you know, et cetera, et cetera. But if you're able to work with these possibilities and see the bigger picture of how these restrictions work together, then you're going to be able to answer this question more efficiently. So yeah, T can't go to a soccer game in this scenario, and T could go to movie. It would just have to be with O, right? So we could have O and T at the movie, um, P at the soccer game, and N at the restaurant. That would be totally fine. Yeah, okay. Let's move on. Okay. So I'm going to keep that um, available. Just we can see we've got like a number of potential solutions within there. Let's also just keep in mind that we cannot have T and P together. Okay. Um, which one of the following is a pair of persons who could go to a movie together? Um, we can never have N go to a movie with anyone other than V. If N goes to a movie, V does as well. If V goes to a movie, N does as well, right? So automatically, I know that A and C are not going to work based on this conditional rule here. Okay, so we can eliminate A and C. If we look at like movie here, right, we actually kind of have an example where O and T go to a movie together because we still have to place T. We know it can't be with P, but if O goes to a movie, T could join O and that would be allowed. So B, we've already proven here that that's possible. So that's great. And if you look at D and E, those are both prohibited by original rules. So T and P can't go together anywhere, and P and O can't go together anywhere. Okay, question 16 now. Each of the following statements must be false except. So if we've got four things that must be false, then which is, yeah, the four things that must be false are obviously the wrong answers. And then the exception to that is the correct answer, that exception would be something that's possible, that doesn't have to be false, that could be true. So we're really just looking for something that's possible. We have a bunch of acceptable solutions already that we've created. We might not have the exact solution that we need here, but we can probably work it out, right? So I'm actually seeing B, only Pike goes to a restaurant. Um, that could be true. Um, that would be totally fine. Yeah. So B should be the correct answer there, and it is. Okay. Question 16B. That's why it's handy to write out those acceptable scenarios. Also, we can see here that was the scenario that I created at the very beginning by following that rule. And we would have P by itself in the scenario that we would have created for that question 15, right? Where we would have O and T together. We could have V and N together, and then P all by itself there. And so, yeah, absolutely, that's possible. Question 17. If N goes to a soccer game, so kind of similar to what we had over here. Oh, the eraser's on. So yeah, kind of similar to this scenario, right? With V going to a soccer game. Not quite the same because N is one of our 3 really restricted players. But it's similar because of this rule that applies to N and B. Okay, so let's draw out that scenario. R. And instead of putting V there, we put N there. But we do know that that means that we can't have V going to the movies. And we know that N can't be with either O or P, right? Neither of can't be with either of those guys. So it's either going to be with V or with T. So now that we have only 2 options, it's, yeah, not a bad idea to show both of those options. So SR dot N could be with V, could be with T. We've got either O or P, right? Gonna fill the other spaces because they can't be together. Okay. And then we don't have V, of course, being able to go to the movies. So in this scenario, where T is with N, V still can't go to the movies, would have to go to the restaurant and could go with either P or O. In this scenario here, where V is going to the soccer game, T would still have the option to go to the movies as long as it's going with O, right? P and T can't go together, but P and O can, or T and O can. So which of the following is a complete and accurate list of the persons, any one of whom could go to a movie? So this wouldn't be a complete and accurate list of the persons who could go to a movie together, but it's any one of them could go to a movie in at least one scenario. They would be allowed to go to a movie. So O, P, and T lists all of the players, any one of whom could go to a movie. So we could have P go to a movie alone. We could have O go to a movie alone, or we could have O and T go to a movie together. Right. So E is the correct answer there. All right. We're going to change one of the conditions. Okay, so if the condition that exactly 2 persons go to a soccer game is changed to require that exactly 3 persons go to a soccer game. All right, so yeah, that really is going to change things, but it's going to make it a lot easier to figure out who goes where because we are only going to have one player go to the movie and one player go to the restaurant. We still need to separate N, O, and P, but we also need to separate P and T. So yeah, let's we're not going to be able to put P in group S. P is not going to be able to go to the soccer game because the only player that P could go to the soccer game with is V, and there wouldn't be like a third player that could be added to that list. So we have to have either O or P here, and then we would have to have T and N there, and then this, or sorry, not O or P. Oh boy. My apologies. I am just mixing up letters here. Okay, so let's start over with that one. We have to keep N, O, and P all separated from each other. None of them can be together. So one of them is going to go to the movies, one of them is going to go to the restaurant. And then for the soccer game, because P definitely can't be there, either N or O is going to be the one of those 3 players that goes to the soccer game. And one of them will go to the movies, one of the 3 will go to the restaurant. And then T and V have to go to the soccer game. N actually won't be able to go to the movies because only one player goes to the movies. And if N goes, then V would have to go as well. So that's going to be either O or P. Yeah, okay. Which one of the following persons must participate in an activity other than going to a soccer game? And that's P. P's not going to be able to go to a soccer game, so C. P is the correct answer. I hope that helps. Let me know if you have any follow-up questions.